I'm going to take the first couple of minutes. Does anybody want me to go over any answers to 7.3 before we start? This is due today. So, tell me if you want me to. We did pages 1 and 2 completely together. So if you want me to go over any answers on 3 and 4, now's the time to ask me. Let me know. You guys there?
Yes.
I got something in the chat. Send it out. If you guys want a question, please put it publicly to everybody so everybody can see that we're asking for the same questions. 30, 31. Okay. I appreciate that. So the last page. First of all, on the last page, which function did you guys pick as the better one, the linear or the exponential? Yeah, it should have been the linear one. And you on number 25, I'm gonna go ahead and just write it down because you need it for that last question. Okay, you should have gotten y equals 25.33x plus 353.17. Is that what you guys got on the linear one? All right, you guys, I'm not going to write down the exponential. You should have gotten that from the graph, from the Desmos calculator. And I would have said this is probably a fairly strong positive linear correlation. On question number 28, when it's asking you to interpret what the graph is saying, what's happening? What's happening in this graph? What are we learning from it?
We're learning that it wants to say that the more you study, the better it's for you.
Well, it wants to say that. It is saying that.
It is saying that.
Yeah.
It doesn't really correlate as multiple people studied less time and got the same.
There's sometimes that happens, but on the correlation tells us the overall picture, and the overall picture says the more that we study, or the more that these people study, the higher they did on the math SAT score. So that's the interpretation of the graph for number 28. Somebody asked for question number 29, and you're going to use if you said that the linear function is the best one, we're going to use the linear function to make a prediction. And we're going to predict how many hours, and hours is the X value, were spent studying when a student earned a math SAT score of 675. And the SAT score is the Y value. So you're going to plug in 675 for the Y variable in the equation and solve for X. So it's going to be set up and look like this. 675 is equal to 25.33x plus 353.17. If you guys didn't finish this part at all for your homework, then you're going to need to go and put this data into the calculator, and you can come back and watch this video later. Okay? But this is something you guys should have already done for your homework. What do you do? What do you do next? So we need to solve it. How do I need to get x by itself. So I'm going to start out by subtracting 353.17 from each side. And somebody's going to need to help me tell me what that is. .83. Okay. Is equal to 25.33x. And then the last step is to divide by 25.33. That cancels. So x is equal to try it again. Anybody at home do this one already? What'd you get?
12.705.
705. Okay. So I'm just going to put 12.7. So 12.7 hours. That's the answer that you put there. So basically, we're making a prediction using the line that was created by the calculator as the best line to fit all the data points that are right here. Somebody asked about number 30. Whoops. I'm going to go ahead and leave this up. It says that use the best regression function. So we're still going to use the linear to find the math SAT score for a student that spends 30 hours. Well, 30 hours, that's the X value. So now you're going to plug in that 30 for X right here and plug it into the calculator and figure out your answer. Okay. I'm not going to do that problem for you guys. I think you guys can do that on your own. Just plug in 30, 25.33 times 30, and then add in the 353.17. Make sure you show your work, so you plug it in right here. Did anybody at home already get that answer? That can tell me what the answer is? 1,113. Okay, we'll just leave it at that. And then, is anybody taking the SAT yet? Yeah. Okay, so do you know the highest score you can get on the SAT?
I looked it up. It's like 1,600.
Okay, so 1,600 is the highest score you can get at the SAT. The highest score you can get on the math part is only 800. So, what's the problem here?
That guy's way too smart, right?
This guy's, yeah, you can't even score this high. You can't even score that high on the math part. So here's another reason why extrapolation is bad, because we're extrapolating to a point that doesn't even exist. In this particular case, it doesn't matter how much you study, how you could study for 1,000 hours. You're never going to get higher than an 800 on that test, on the math SATs part. Okay, so again, giving you guys a whole bunch of reasons and ideas why extrapolation is bad. Okay, interpolation is fine for making a prediction within our data, but extrapolation is not good. And here's another reason for it. All right. Any other questions on 7.3? You guys gonna get that turned in today? You already turned yours in, right? Okay. So here's what we're gonna do today. In order to get your free 100, I need you guys to be, especially at home, to follow along. There is no Nearpod or anything. If you want to jot down some notes, you can, but I'm going to post these notes a little bit later for you guys to review at. But this is this. You're going to use this stuff in a project that you guys are going to begin next week. Okay. For you guys at home, in order to ensure that you are there, you either need to participate by keeping your camera on, or if I ask a question, I need you to put something in the chat. Please put it in the chat publicly, not privately to me. Okay. If I don't see that you're participating, then you'll have to watch this later for participation through a puzzle. Linear equations, exponential equations, we've done. I'm going to talk to you guys about something new today, and really kind of goes along with a lot of different things that we're talking about, but I'm going to try to relate this to what we've been through in the past year. Okay. I can't believe, can you guys believe that it's been a year since we've all went in lockdown and didn't have any toilet paper at home? All right. How many of you ran out of toilet paper and couldn't find any?
My parents were part of the problem.
Your parents were part of the problem? We got really lucky that we got some toilet paper before this all even started. Like, we were in Laredo, and my fiance's mom, she always like sends us back to Austin with she always buys us stuff. Like, she buys us like these huge paper rolls of toilet paper from Sam's, and so we had a bunch already. You're from Laredo too, Leslie? That's where my fiance is from. And so we had a lot of toilet paper. We had to give some to some neighbors because we have these older couple there, so neighbors, and they couldn't get milk, they couldn't get toilet paper, so we were just kind of sharing everything in our little complex there. So when back in March of last year, so it's barely been a little over a year, and actually really starting in January of last year is when we started hearing first cases of coronavirus hitting the U.S. And what happened? We started out with like 1 or 2 cases, and a couple days later, then you heard it was up to like 15 cases. And then a couple days later, now you're at 30 or 40, and then we got to the hundreds, and then we got to the thousands. Did anybody watch the CNN or any of the news stations have that counter on the side? Every time they turn the news station on, it was just like new coronavirus cases, new deaths. And it was growing super, super fast. Not just growing fast, but it was growing exponentially. Okay, exponentially fast. But is it always going to grow exponentially? Why not? Why won't it continue to grow exponentially?
There's the same amount of people, and then like just the caution people take.
Okay, the cautions people take. So, what are some of the things that are going to stop it from growing and spreading? People getting the vaccine now, people wearing masks, people social distancing, people staying at home. We shut everything down, right? Okay. Even if we didn't do any of those things, though, is there something else that would stop the spread of the virus growing exponentially?
Getting better.
Getting better. Our immune systems get better. Or most of you guys know that if you get the coronavirus, you're not 100% immune from getting it again, but you're most likely not going to get it again. Okay, that's we've seen that through over time and time again through science. However, even if we didn't have a vaccine or social distancing or mask, we can't always grow exponentially, because what happens when everybody gets the vaccine, or what happens when everybody gets coronavirus? If everybody gets it eventually, then it can't grow anymore. It can't affect any more people. Okay, we're going to reach what's called a carrying capacity. Have you ever heard that term, carrying capacity, before? Okay, populations have carrying capacity. We talked about the other day the city of Kyle blowing up. It's growing exponentially. Year 2000, when I was in high school, there was only 5,000 people here. 2020, there's like over 30,000 people here. It's growing exponentially, but it's not always going to grow exponentially. There's going to be a carrying capacity in this area. Why?
Because there's population.
Why would the population stop to grow here in Kyle?
We don't have any houses.
We don't have any houses or room left. Okay, what's north of us? Buda and Austin. What's south of us? San Marcos. What's east of us?
Nothing.
Yeah, well, there's nothing yet. There's Euland out there. The boundaries eventually get there. West, you get far enough to get Wimberley and Dripping Springs, right? Eventually, the boundaries will be so far that the city of Kyle cannot grow anymore, and it'll reach that carrying capacity unless we start moving up in super high-rise buildings or whatnot. Okay, so I want to model that for you. And if this was another year, we would have done this as a class. And I usually do it not with the coronavirus. Obviously, it didn't exist before that. I used to do this with a zombie apocalypse because I love zombie movies. We would start with one person, like Alyssa would be zombie number one, and then she'd start infecting everybody else to become zombies, and we'd see how long it takes. Okay, can't model that this year with the pandemic, but I'm going to model this. Imagine this group of 100 people in a small community, and they're isolated from the rest of the world. If a group of people is completely isolated from everybody else, is it possible for them to become infected by a particular virus like the coronavirus? If they're completely isolated? No, it's not. It really isn't. Okay, unless that virus existed in that community already, it's not possible for them to contract that virus. Okay, we see this already happening in small indigenous tribes in indigenous places of the world where they're still not contacted by advanced civilizations. Did you know that there's still tribes and stuff like that? And it's really, really important that we don't contact them, because what happens is they are not immune to the diseases that we are immune to. They can die from a simple flu. They can die from things that we haven't seen before, seen in a long time, like malaria that we're vaccinated against, or polio, or hepatitis. Those things you guys are all vaccinated against since you were kids. Okay, but those tribes, they're not vaccinated against those things. We can bring those things to them, and it's really important that we don't contact them. So imagine this community of 100 people. One person leaves the community, goes to a big city, they get coronavirus, they're asymptomatic, they don't know they have it. They come back to the community, and what happens? They start to spread. Okay, they begin to spread. There's patient. Do you know what the first person in a pandemic is called? what patient number they are? Patient 0. Okay, so this is patient 0 right here. Day 1, patient 0 meets with somebody else. They infect one other person in the community. Now there's 2 people infected. Day 2, those 2 people infect 2 more people. Now there's 4 people infected. What do you think is going to happen on day 3? 6?
10.
You said it right the first time. If 2 infected 2 more on the first day,
8.
and then on the second day, 8 people will be infected by day 3 because 4 more people will infect 4 more people. And then that continues to kind of double some days. Some days it doesn't. But by day 6, look what happened. 51 people are infected by the coronavirus. And now we have a little over half of the population just in 6 days. So what is it? What models this? We'll take a look. This is a graph I created from Desmos of the days since the coronavirus was introduced into that community and the number of people that are infected with it. All right. How would you describe this correlation? Help me describe the correlation. And those of you guys at home, put something in the chat. Tell me how strong it is, what direction it's going, and how what form is it in. How strong is it? No, it's more than that right here. It's very strong. Very strong. Is it positive or negative? It's positive. It's going upwards. And what is it? Linear, exponential, or something else? It's definitely linear. I mean, it's definitely exponential. Sorry. Why is it exponential? Because it's making that curve up. Okay. And let me prove it to you. That's a good point. I have it already on here on the Desmos calculator. Watch this. Here's the linear equation for that graph. Does that look like it matches up? No. But here is the exponential equation. That's why it's exponential. We can see the shape growing rapidly. The exponential graph matches it almost perfectly. Okay, almost perfectly. Yeah, good job switching your answers there, guys. All right, so let's take a look. Is it going to continue to grow? Is it going to continue to grow exponentially? Yes or no?
Yeah.
Well, what's going to happen eventually?
So,
Say that again?
You're gonna meet, or I don't know.
They're going to what? Meet? Well, yeah. Are people going to continue to get infected? Yes, that's true. People are going to continue to get infected, but are people going to continue to get infected at the same rate? No. It's eventually going to start slowing down. Well, look at this. I flash forward 2 more days. Day 8. 89 people. I know. 89 people have got the coronavirus. Let's do 2 more days. On 2 more days, only 6 more people got infected. Now we're at 95. And it took a total of 3. There's only 5 people here that are not infected. But it took a total of 3 more days before finally everybody got infected by the virus. Okay. 100% of people got infected with the coronavirus. Hopefully we didn't lose too many of those. Okay. Well, what does the graph look like now? It plateaued. It started to level off. Okay. This is no longer an exponential function. What have we done? We've reached carrying capacity. Everybody in the community got infected with the coronavirus. Okay. You ever heard the term herd immunity? Have you heard that in the news lately? What we are as a country, we as a world are trying to achieve what's called herd immunity, meaning we have enough people infected by the virus, we have enough people with the vaccine that we now have a place that we can live in where enough people either have got the antibodies because they had it before or got the vaccine that transmission is super, super low. Okay. Take for example, in this classroom. Have any of you gotten the coronavirus? You got it. Okay. So Alyssa's got it before. She's got antibodies. I have the vaccine. Any of you vaccinated?
I got the first one.
Okay. Let's just say y'all here's got vaccine now. So there's 3 out of the 5 people in here that have either got antibodies, can't get it again for the most part, or got the vaccine and can't get it for the most part, right? It's not 100%. 60% of the people in here, 3 out of the 5. Do you think the transmission, if one of us can give it to one of you guys, I think it's a big possibility that one of us can give it to you guys?
I think City?
What's the possibility? I mean, is it really high possibility or really low possibility that one of us can give it to you guys? It's probably really, really low. It's a really, really low possibility that Alyssa gets sick again. Okay, we've seen it happen, but it's really, really low. It's a really, really low possibility that Yahir or I get infected because the vaccine protects us. Depending on which one you get, the vaccine protects us about 97% of the time. Okay, I got the Pfizer one.
Pfizer?
Mm-hmm. You got Pfizer? What?
I got the modern
Moderna. That one's also about 95, 96%. Okay. The Johnson & Johnson's only about 77%. So if he had gotten the Johnson & Johnson, y'all's chances go up a little bit of getting infected. But we're trying to reach herd immunity. This right here is reaching that carrying capacity of the high. Everybody's either infected or everybody's either immune. One of the two. Okay. This is actually not an exponential function overall. It started out that way, but it's actually not that. It's what it's called is it's called a logistic function. Okay. This is the new thing that you guys probably have never seen before. Logistic functions start out exponential, but they eventually level off. They plateau. And they level off either at the carrying capacity or whatever the maximum growth is. We see this in our growth of you as a baby growing up to be now, right? You grow from an infant to a toddler super, super fast. You grow to a adolescent super, super fast. As soon as you get to be like 18, 19, 20, 21, you stop growing, okay? You're going to grow really fast, and then eventually you're going to stop growing. You plateau off. You level off. You see the difference between the two graphs on the screen, right? You already know what a exponential equation looks like. That's what it looks like right here. This is the equation of a logistic function. Take a look at that. Okay. I'm going to show you how well this fits from the, I created this again this morning. I'm going to show you how well this fits now. Here's that same function that I had. I put in all the days and all the infections of that community. And watch, the linear does not fit it very well. Okay. The exponential no longer fits that graph. But watch how well the logistic function fits. Okay. And that's a logistic function. But there's 3 variables this time and not just 2. So you have an A value, you have a T value that goes here, and a B value that goes here. Put it together for that equation. One thing that I wanted to show you, the last thing I want to show you guys, this is the last slide. God, if this will load, is that there is an asymptote on this graph. You may have remembered asymptotes last year when you were doing rational functions. Do you remember that from your Algebra 2 class? You do, maybe? You remember the term? Okay. Asymptote. There is an asymptote, which is always the A value. It's always the number that's on the top of that equation. Notice that right here. You have the A value, you have the B value, and the T value the calculator is always going to give you. Calculator is not going to give you E. Do you ever notice that little E button on your calculators? Look at your calculator right now. Do you see the E on there? Okay, E is not a variable. It's actually a constant. It's kind of like pi. It's a constant. And whenever you put these equations into the calculator, you actually use that E button on the calculator. They even have it on your basic scientific calculators on your cell phone calculators. So you can find that E button there. Next week when I give you guys, actually, before I say that, tell me, what do you think the A value is going to be in this particular problem? The example that I just gave you guys. What's the carrying capacity of the problem that we just did? What do you think? What was the limit that we could never go above 100? There was 100 people, right? There was 100 people in that equation. And if I go back to my graph right here and take a look at what it predicted A is going to be, look how close it is, 99.0066. Now, it's not perfect because it's creating the equation from the data, but look at how close it was to that carrying capacity. And we knew, and realistically, that it cannot be over 100. We can't infect more than 100 people that are in this community. Okay. So next week, what I'm going to do is on Tuesday, I'm going to give you guys different sets of data, and you're going to make a linear, you're going to make an exponential, you're going to make a logistic, and you're going to choose which is the best equation for your data, and you're going to describe it. And that's going to be your project for your major grade. It's a really short, small project. Okay. Anybody have any questions? Anybody seen these logistic functions before? How many? I mean, the news right now, you might start seeing these types of graphs as more and more people get vaccinated. You're going to see the number of deaths, the number of infections, the rates at which people are infected are going to start to level off. It's going to start to slow down. You're going to see it like that. Even if you see it as sometimes you might see it as a histogram that's starting to level off this direction. It's not going to grow anymore. Any questions?